Hello, everybody. This is Mrs. LP, and this is the geometry lecture for Friday, February 19th. This is part 2 of our lecture series for slopes of parallel and perpendicular lines. What you're going to need for today are your notes from yesterday, which is part 1 of the lecture series of section 2-4. And you're going to need that 2-4 Math Excel PDF that I posted to Google Classroom for today, as well as some note-taking materials. And if you look at the image over here to the right, you'll see that you have under Q3 week 6, and here are your dates, that PDF is attached right there, right underneath the instructions for today. What we are going to be doing is going over the questions posted on this assignment, as well as some handy tools and tricks to find your answers. One of the goals I have for today is to have a little toolbox. We are going to fill in the essential equations we need for this section, and you're going to keep it with you. They are going to help you out. Okay, so take a power pause moment to gather your materials. Okay, so let's write these equations that I'm going to give you right now on the margins of your paper. Put it in a separate piece of paper, put it somewhere easily accessible that you can refer back to, somewhere that you're maybe not as likely to scribble all over, unless you're adding things to it. But this is going to be our toolbox. This is going to be the information we need. Let's say we are given 2 points, an x1, a y1, and an x2, and a y2. You only determine where you have your x1 and your y1 based on this. x1 is always less than x2. y1 and y2, they are just along for the ride. It doesn't matter what they look like. You just ignore them for a minute. Look at x1 and x2. Is it really x1? This guys can be written the other way around. You can have your other coordinate here and determine that is x2 and y2. But this is important. Whenever you're looking at which one is your x1, your y1, x2, y2, your x1 is always less than your x2. Your y's are just along for the ride. Okay? With that being said, if you're only given 2 coordinates, you can most certainly find a slope for those 2 coordinates. y2 minus y1 over x2 minus x1. That is something we can totally do with this. All you need is 2 coordinates and you can get another equation going. Okay? Now here's something else that we're likely to need. And this is something that you guys are familiar with. Y equals mx, x plus b, our slope-intercept form. We're familiar with that. We know this. We can do things with this. We're going to certainly use that here. Now here's something else. Whenever you're dealing with a parallel line, so I'm going to do my little parallel signs here, your slopes are equal. When you have perpendicular lines, your slope, your initial slope, you need to flip it. So now it's in the denominator, that numerator, and you need to give it an opposite charge. So here we had a positive m. We're going to flip it upside down. M is now in the denominator. And we're going to give it a negative sign. It's the negative reciprocal of your original slope. It's the complete opposite. We have flipped it upside down and made it negative. If it's already negative, you're going to make it positive. You're going to make it the complete opposite of your original. So these are important. Okay? Now, if you are trying to find the linear equation So let's see, linear equation, line that passes, so I'm going to put a star there because this is a one that we're going to use, passes a point. And this is a particular point that they're going to specify. And is parallel. You're going to first identify your slope. So I'm going to put that here. Step 1, identify your slope. Right? For parallel, your slope is going to be that of the original line. Let's say you're given something for perpendicular. So I'm going to say or perpendicular. Underline that. For perpendicular, you're going to have your original slope. You're going to flip it upside down and give it an opposite charge. You're going to make it the negative reciprocal of your original. Okay. So the first step is to ID your slope. Then you're going to use this new slope, right? And you're going to plug into y equals mx plus b using the coordinate they give you, using that coordinate point. And solve for b. After you do that, you're going to plug it back into y equals mx plus b. So here's your toolkit. Here are the things you're going to need for this section, especially for this assignment. So let's see what the assignment looks like. Now that we have our toolkit in place, let's look at number 1. What are the equations of lines M and Q? So we're looking for this line and this line. We have this guy here in the middle, line N. That's going to play a critical part for us. Now, look at your toolkit. Are we given enough information to find the equations for lines M and Q just by themselves? Do we have any of that? We have, here's some givens. We have for line N is perpendicular. See this little 90 degrees right here? Because it is 90 degrees, it is perpendicular to line M. Line Q is also perpendicular to line M. So we can observe that N is parallel to Q. That's going to help us out. Let's make another observation. We are given 2 points for line N. There's only 1 point in line M, as in Mary, and only 1 point in line Q. Well, since we know that N is perpendicular to M, why not use these 2 points to find the slope for line N? Get that perpendicular slope for line M, and then start plugging in this other point. That'll work, right? So we have a game plan. Right now, we are going to find the slope for line N. Only because we have these 2 coordinates. So I'm going to write those guys down. I have on line N 1, -1, I also have 4, 4. All right. At the beginning of our toolkit, I did say that when you have 2 coordinates, that's all you need to get some math started. We just have to identify which one of these 2 points has your x1 and your y1. Remember that x1 is always less than x2. 1 is less than 4. So here's your x1. y1 is its date. It is just along for the ride. x2 and y2. Now let's use those. I'm going to plug them into the slope equation, which is y2 minus y1 over x2 minus x1. So the slope for line n, because we're looking at those 2 points, right? So I'm going to put a little subscript n there, equals y2 we've identified as 4. Oops, I can't seem to get it without, there it goes. Minus y1 is -1, which is really just going to be 4 minus the negative number is going to be 4 plus that number. And x2 is 4 minus x1 is positive 1. So we just add across. 4 plus 1 is 5 over 4 minus 1 is 3. Now I don't want to simplify this. This is okay. Let's keep it there. Because I know that the slope for m is perpendicular to that of n, right? So I'm going to take the slope of n. I know they're perpendicular because of this 90-degree angle right here at their intersection. And I'm going to flip it, and I'm going to give it an opposite charge. 5 over 3. When I flip it upside down, it becomes 3 over 5. This is positive in the original slope, so I'm going to make it negative. That's it. That there is your slope for line M, which is perpendicular to N. Okay. Now, apply that 3-step method for finding the equation of a line that passes through a point. So I'm going to find the linear equation for line M, right, as it passes through this point right here, this 2, 6. We're given a coordinate that it crosses there. That's nice. And is perpendicular to line N. Lucky for us, we already found that slope. Remember, the first step in the toolkit says to find that slope. ID your slope. Well, the slope for line M, which is perpendicular to line N, is -3/5. Okay. Your next step was to plug this in slope-intercept form. Let's do that. So I have a y right here in this coordinate. Here's my x. I'm going to plug in my x and my y and this m. We're going to need that. So y is 6 equals m is negative 3/5 times x is 2 plus b. Now we have to solve and solve for b. So let's do that. I'm just going to multiply across here. So 6 is just along for the ride equals negative 3 times 2 is negative 6 over, and then there's an invisible 1 there in the denominator for 2. 5 times 1 is 5 plus b. Okay, I just need b alone. So I'm going to add this negative 6/5 to both sides. So plus 6/5, so they can zero out, they cancel out, right? They get to cancel, and then plus 6/5 here. So I'm going to scroll up. There we go. We got some room now. Okay, so I've added 6 over 5 to both sides. I'm actually going to rewrite that. It's still the same thing, but I'm rewriting it. Oops. Equals b. We're almost there. We just had to solve for this. Now, I would like to combine these guys, but I need a common denominator. Remember, under the 6, there's a little invisible 1. And I'm going to multiply this 6 by 5 over 5 to give me that common denominator. So you multiply across. 5 times 6 is 30 over 5 times 1 is 5 plus 6 equals b. Oh, not plus 6, plus 6 over 5. There it is. Now I can add these guys together because they have this common denominator of 5. So 30 plus 6 is 36 over 5 is equal to our b. All right. Now let's combine what we have, because the third part, the third step, was to, and then refer back to your toolkit if you have to. Plug m and b back into your slope-intercept form. So you'll end up with y equals our m. Remember to take the perpendicular slope is negative 3/5 x plus b we just found to be 36 over 5. So there's that linear equation. This is for line, oops, M, M as in Mary. Okay, so got one part there. Remember, it also asked for the equation for line Q. So let me set you up, but you are going to have to find this. So find the linear function, the linear equation for line Q as it passes and we are given a coordinate, we're going to use that same coordinate that M passed through because that is an intersection for it. 2, 6, and is perpendicular to line M. And I'm going to put here in some brackets. Remember that Q, line Q, is also parallel to line N. We found that slope earlier for line N. Okay, so your first step is going to be to identify your slope. Well, I'm going to scroll up. Notice that the slope to line N we found earlier. It's right over here. The slope to line N is right there, right? Whoop, this guy here. It was 5/3. If line N is parallel to line Q, they're going to have the same slope. I'm going to steal this. 5/3 is my slope for Q. Slope for N is the same as the slope for Q, which was 5/3. Excellent. Now, you guys have to plug your slope and your coordinate 2, 6 into y equals mx plus b and solve for b. When you're done with that, you plug in your m, which is your slope of q in particular, and b back into y equals mx plus b. Okay, so I've given you the setup. We found the equation for line M, but number 1 also asks for the equation for line Q. Now, let me give you some other information for number 2. Now, this assignment is riddled with having to find slopes. If you look at number 2, it says lines K and N intersect the y-axis. Here is line K, and here is line N. What is the equation for line K? We are given here that K has a point, it has a coordinate to play with, it's -2, 6. But it doesn't give you any other coordinate. Notice here, though, there's an intersection. Check this out. I'm going to say that's about at, and this is not to scale, 0, 3 for this intersection here. So now you have 2 points for line K. What can you do with 2 coordinate points? Well, for one, you can find a slope. Then you plug that slope into slope-intercept form using this point, and you can find your y-intercept. Or you actually have your y-intercept here. See? It's about 3. So you just plug that in to your slope-intercept form. So that's for K. What is the equation for line J? Where is J? Let's see here. J is right here, and it is perpendicular to K. It's a 90-degree angle right here. That's nice. So we're given a whole mess of extra information. You might or you might not use this information. You most certainly can fill things in, but for lines K and J, you only really need these 2 points, -2, 6, and 0, 3. And knowing that K and J are perpendicular to one another. Okay, so that is some information for number 2. Number 3, you're going to be given a table of values. Do remember, and here's a little bit of a hint for number 3, because remember, as much as I would love to walk you all through it, you do have to think for yourselves here. Number 3, remember that y is the same thing as saying f of x. These two are interchangeable. Okay, and whenever you have something like y equals f of x and the other y is going to equal g of x, what they're really saying is that this is one line here, that's one line, and then this one over here is a completely different line that they're going to call g. You're going to be given a table of values. It's going to be x, and then you have here, there we go, there we go, 0, 1, 2, 3. Then you have f of x here and g of x here with values written in between. You can refer to the PDF for those values. Now, if it's easier for your eye to track, and this is very understandable because this is very jumbled, you can separate these two out. So this is one table for x and y values, specifically f of x. And then these two columns here. So these two columns there, oops, and those two columns. And then you'll have your g of x written here, okay? So you can separate them out. Find the slope. Determine if they are parallel. So find m. Find m here. Use 2 coordinate points there. Are they equal? That's your central question there. Okay. And numbers 4 through 6 are multiple choice questions. Just read the answers carefully. They will try to throw you off. All right. You guys let me know if you have any questions along the way, and be safe out there.